So the first question I think should be pretty much straight. I think everybody should have got it. How about the first question, guys? Paritosh, you're done.
Fine, done.
Srinivas, done. Manoj, first question.
Yeah, we sure done.
The second one, how about the second one, guys? Print the array in the reverse order using recursion.
Yeah.
Yeah, so I also done. Yeah.
Correct. The third one is also should be okay, guys. Third one, how is the third one? Is it done? Length of a string using recursion. You don't have to use any string methods to find the length. You only can use the recursive concept to do it.
So Vishwa, like I converted that to a char array and afterwards did it.
That is fine. So basically, I didn't want to use any length method for the string to find it. That is
Yeah, even I also did in the same way. So I converted into a array.
That is fine. That is fine because anyway you have to get some way to iterate through the string, right? So either you'll have to use the string substring method or you'll have to convert it into the char array and then iterate.
Okay.
I'm more interested in the question number 4 because this is the most classical example of recursion.
Yes,
We'll try to solve this problem today and we'll try and just try to focus on how I'm trying to build the solution, how I'm trying to build the logic and moving onwards. If you please stop me there itself because this is very important. Because Tower of Hanoi is one of the very classical example of recursive concept. And if you understand this question and if you can solve on it on your own, trust me, like you will never get stuck in any recursion question. And also, if you solve this question using the recursion, you'll really appreciate that how powerful this recursive concept is, right? How easily you can solve the problem. Okay. So before I start, I again will try to repeat few things which I've already repeated in the previous sessions. So in a recursion, basically, whenever you write a recursion, there are 3 important things that you have to write. The first one is the termination condition, right? And the second and the third, irrespective of the order, like they can be in the different orders. It should be, logic plus recursive call, right? In a recursion, there are basically, 3 things that you do. First one is always fixed. Like the first step in any recursive function should be the termination call, termination condition. And the second and the third, their order may change. Sometimes you write the logic first and then the recursive call last. That is known as the tail recursion. And sometimes you write the recursive call first and then you write the logic. That is called the non-tail recursion. What is the difference between these two? So whenever you're writing a tail recursive call, all the elements in the array or any data structure where you are storing it and you are iterating over it using recursion, elements will be assessed in the same order it is inserted into that particular data structure. But if you write the logic after the recursive call, it will be assessed in the reverse order. Right? These are the few things that we learned about the recursion. Another key thing that I told you that in the case whenever you are writing a recursive function, you should be very clear about the recursive function. You should be very clear about the meaning of that recursive function. So whenever you write a recursive function, you don't worry much about the implementation. You just think about what this recursive function will do. And if you understand the meaning well, the writing of the next steps will be very simple, right? So now coming back to the Tower of Hanoi problem. So basically it says that there's a Tower 1, there's a Tower 2, and there's a Tower 3, right? Tower 1 has say endpoints initially, and all the endpoints are arranged one over the another. And the condition is the coin with the largest diameter will be at the bottom, and the coin with the smallest diameter will be at the top. Now what you have to do is that you have to move all the coins from the T1 to T2. So finally the state will be like this will be now 0, and initially it was 0. And initially this was 0. Finally this should be also 0. So you have to bring this was suppose initial stage, and this is my final stage. So initial stage was that T1 is having endpoints, T2 and T3 are 0, and final stage is that T2 is endpoints, T1 is 0, and T3 is 0, right? So T1 is my source, T2 is destination, and T3 is the auxiliary that you can use it for the shifting of the points. This is first thing. The second information that has been given is that at the time you can move only one point, right? So you can move all the endpoints from the 1 and put it on the T2. You can move only one point at a one time, right? And the third important condition is that you cannot put a larger diameter point on the top of a smaller diameter point. So always a smaller diameter point has to be put on the top of the larger diameter point, right? So these 3 are the condition. I think everybody is clear about the question condition, no doubts in that. Perfect. So far so good?
Yeah.
Perfect. So whenever you have a recursive problem, always try to break down into a smaller use cases first and see how it works. So suppose if n is equals to 1. So if n is equal to 1, in that case, n is equal to 1, this is the initial condition. So if n is equal to 1, I can simply just pick the one point that is lying on the table 1, on the tower 1, and I'll put it to the tower 2. So it will just like, it will become 0, it will become 1, and it will become 0. So the number of steps will be equals to, steps will be equal to 1 only. Right? Let's try to see how it happens in the n equals to 2. Okay. So if the n is equal to 2, right, this was the initial condition. So now I have 2 coins. So what I can do is that I can pick the topmost coin. So first step, what I do, I pick the smallest coin and put it here, and here it is 0, and here it becomes 1. So this is the first step. Now the T1 will have the largest diameter coin, and the T3 will have the smallest diameter coin, right? So this is the step 1. And then in the next step, what I do, I put the largest diameter coin from the T1 to the T2. So now this becomes 0, and this becomes 1, and this becomes 1. And now the largest diameter is the bottom. So what I can do is that I can pick the smallest diameter coin, which is there on the T3, and put it on the T2 back. So this becomes 0, and this becomes 2, and this becomes 0. So this is how it got arranged down. So in this, the number of steps that it took is around is equal to 3, right? So as I see, for the initial two things, it is simple, but again, when the value of n increases, its number of steps will become much higher. And this is how we'll have to proceed this way, like, smallest I have to move to the T3, then I have to move something to the T2, then again I have to move from the T3. So this is how we have to progress, right? So far, so good. Or you guys are with me? Any doubt so far? This
Yeah,
step is
fine.
clear, right? So n is equal to perfect. Now I have to define it for any generic number n, right? And I understood that the bigger problem can be has to be moved into a smaller problem. So for example, when I was at stage this is a new problem. But when I came into this stage, when the T1 is having 1 point and the T2 is having 0 point, this is similar to the previous state problem, like this state problem in which I just moved from the one step. It moved 1 point from here to here. So one pattern that I can see here is that as we move on, we can always break down the bigger problem into the smaller ones, and that is a small hint that we can use recursion here. Okay. Now, whenever you have to write a recursion, first of all, you just think about what are the constraints involved in that particular problem. So in this problem, the different constraints are that I have n coins. This is the first constraint. The second constraint is that there are 3 towers that have been given to me: tower 1, tower 2, and the tower 3. And the another constant that is that at a time I can move only 1 coin. And another constant is that I can only keep a smaller coin on the top of a larger coin. The vice versa is not allowed, right? So let's try to first create a function. So say I create a function called public and find number move. Okay. This takes first the number of points which I have, and then it takes what is the starting point. So I call it s is my starting point. Then it has to move to the destination, okay, and then it has to do auxiliary. This is suppose I have defined a function. Okay. So before we write anything inside a recursive function, let's try to first understand what is the meaning of this function. So the meaning of this function, we can say it like this: that find number moves, or I can just, so if there's a function called moves, in that if we provide the number of points and I tell them, what is the starting, what is the destination, and what is the auxiliary, it will tell me how many number of moves it needs to move n points from S to D using A as the auxiliary. The meaning of this function is that function move tells that how much moves it takes to move n points from S to D using A as auxiliary. This is the meaning of this function. Don't think about how it will do, but if there is a function, if you have this function, you can call this function to get this number, right? Make sense?
Yeah, sure.
Okay. Now a follow-up question. So if this is the function definition, if you guys are clear about it, can you tell me what will be the meaning of this function? What will this return if I do n minus 1, if I do s, b if I do a? I'll just ask one by one. You tell me what is the meaning of this function. So what it is trying to explain is that it will tell me how many moves it takes to move n minus 1 point from S to D using A as the auxiliary.
Okay.
If I just change this to this, what is the meaning of this, Manoj? Can you tell me now?
Yeah, so it is like we'll move n minus 1 coins from S to A using D as an auxiliary. But
Perfect.
I am a
Perfect.
bit confused actually. S to D and S to this A, SDA1 I understood. But here, like, how will pass the values after that?
You don't have to understand. You don't have to worry about the implementation details. Just understand the method definition. You just thought that you have a magic method in which you
Yes, yes.
pass this, it will get you that information. This method says that if I give you n minus 1 points, it will tell me how many steps n minus steps it will take to move n minus 1 point from S to A using D as auxiliary, right? Right. If I say the same thing, what is the meaning of this, Vivek?
It tells like how many moves we should do to move n minus 1 coins from D to A using SS auxiliary.
Perfect. So you understood, right? We know the function. So I'm right now or dot. I don't know how I'm gonna implement it, but I just know that okay, I have a function, and in the function, if I pass the arguments in this order and I pass the number, this will tell me, how many moves it will take to move from the source to the destination using the third as the auxiliary, right? So now let's not talk about the implementation first. So now suppose the T1, so suppose right now the source has something called endpoints, and suppose destination has 0 points, and then auxiliary has again 0 point. This was the initial state, right? Now if somehow I can magically move n minus 1 points from S to A, okay, from S to A. So for that, what I'll have to do is that I'll have to make a call to this function moves, and in this I'll pass what endpoints n minus 1. Suppose I have to pass top n minus 1 point. So I put n minus 1 point, and I have to move from the source, and then I have to move to the to A. I want to move it to the A, so I put the destination as A, right? And auxiliary, I want to use this as the auxiliary, so I put as the D. So what when I call this function, right? What it will do is that it will move n minus 1 points from the S to A using D as the auxiliary. So after this, the state should become equals to, it should become S should be becoming 1, right? And this should become 0, and this should become n minus 1. And the number of steps that is needed is that it's the value of this one, which is say S1 step. So this is the S1 step that it took to come from this state to this state. Right? Don't think about how it is getting implemented. Just think of that you have a magic function, and if you pass this to this, you get the number of steps. So what I did is that initially my situation is like this: that my source has having n points, my destination is having 0 point, and my auxiliary is having 0 point. This is my initial state. Okay. Now in this state, I want to move n minus 1 top points, n minus 1 top point from the S to the A. So to do that, and let's not figure it out, let's not worry about how it will be done. Just think about the use case. I want to do this. And for doing that, do I have anything? Yes, I have a function to do that. And what is that function? That function is this moves, right? So if I have to move from the S to A, I have to put S as the source, and I have to put A as the destination. So I put S as the source, I put A as the destination, and the remaining, the third one, I put it as the auxiliary. So third one. So in this method definition, the first one is the source, the second one is the destination, and the third one is the auxiliary one, right? So I have to start from the source. I put the source as S. I have to move to the, I have to move to the A. So I put A as the destination, and I have to use the third one as the auxiliary. So the D is used as the auxiliary, and this will move n minus 1 points from the source to the destination using D as the auxiliary. So after this method has been invoked, the state will be like this. So here n minus 1 kind has been moved, so it will be only left with 1 point, and all the endpoint would have been moved to the A. So here the number of points will be n minus 1, and the D, which is middle one, which is right now for the last operation was being used as the auxiliary, it will have 0 nodes, 0 elements, 0 points. Now the point that is left on the S is the largest one, because we picked the n minus 1 top points, right, in this move. So the point which is left at the S is the largest one. So what we need to do is that now move that one largest point to the D. Now since I have to move only one point from the S to the D, I can do in just one step. So it will just take one step, and it will get converted into this state. So now S will remain 0. The D will have the one largest point in it, and A is having n minus point still. Now what I need to do is that I now somehow have to move all this n minus 1 points from the A to the D. Now what I have to do, I have to move all this n minus 1 point from the A to the D using S as the auxiliary. So again I will make a call to this function. And here what I do, I have to move n minus 1 points, but I have to move from the A and I have to take it to the D, and I have to use S as the auxiliary. And this is, say, suppose S2. So when I do this, the final state will happen like this. So it will be 0. N minus 1 points would have further moved to the D. So the total number of points at the D will be now n. And the number of points that is left on the A is 0. All the n points has been moved to the D starting from the S, right? So in this, I had to do these many things. So the total step, if I have to calculate, then it will be equal to this plus 1 plus this, right? This will be my total number of steps. Any doubts here, guys? Any questions on this? Just try to understand. You don't have to memorize anything, because if you start doing that, then it will be a tough job. Try to understand what I'm saying. So far, the only thing that we have done is that we have defined a function. We have understood what that function do, and based on that, using that function, we have tried to first formulate the logic. We are still not talked about the implementation detail. We have just talked about the method definition. Are we good? Or if you want, I can repeat again if you have any doubts.
Repeat again quickly,
Okay.
like.
Okay, but please be very, please be
Yeah,
very focused. I'll start
Yes.
from the beginning itself, right?
Okay,
The
okay.
key to solving any good recursive problem is that you should be, very clear about the method definition, right? Whatever method that you write, you should understand that what it does, right? So here we have tried to write a function called moves, okay? And what the move function does is that in this move function, if you give the number of points, and if you tell it what is your starting point, if you tell it what is the destination point, and if you tell it what is your auxiliary point, it will tell you the number of moves needed to move n point from the starting to the destination using auxiliary, right? The S is not indicating starting, so don't be confused with that. You just only have to take that, whatever is the second argument will be my starting point, whatever that is the third argument of this method will be my destination, and whatever that I put into the fourth argument will be my auxiliary node, auxiliary table, or auxiliary stack. Okay, and this gives me the total number of moves. Then I ask you to tell me what is the meaning of this. So this basically means that you have to move n minus 1 points from S to D using A as auxiliary. This is the meaning of this. Again, when I move like this, I change it to, this is the meaning of this method will be the number of moves needed to move n minus 1 point from S to A using D as the auxiliary, right? And the meaning of this function will be number of moves needed to move n minus 1 points from D to A using S as auxiliary, right? So now what we are doing is that we are trying to solve this problem with this method definition that we have created. We are not worrying much about how it actually does it. We just worry about that, okay, it is doing, and I believe that if I have this function, I can do this. Okay. So I had initially this state. I had as S, I had like n points. At D, I had 0 points, and at A, I had like 0 points. Right. So I thought of, I have this method, and if in this method I pass the points, I pass the starting and the destination, it will simply move it the way I want, right? So I told that, okay, you do one thing, move n minus 1 points on the top from S to A. So for that, I have to call this method like this. I have to pass n minus 1 points. I have to say that, okay, S is my starting point, A is my destination, and D is my auxiliary. So as soon as I call this function, this will return me the number of steps that was needed to do this. So S1 I got. And after this, the state is like this. S was having 1 point, D is having 0 points, and A is now having n minus 1 point, because this would have moved n minus 1 point from S to A using D as the auxiliary. So n minus 1 points have been taken from the S, and it has been moved to the A. D is auxiliary, right? Now, okay. So now my problem has reduced a bit. I have moved few of the points from the S to the A. Now, the S is remaining the largest coin. Bottommost coin is the largest diameter coin. So that should go to the the at the bottom of the D also, right? I move that one coin from the S to the D. So after this one more single step, the S has now 0, the D has become equals to 1, and the A was already having n minus 1. So in this, I have not done anything change in the A. So now after this one more step, the S has 0 points left, the D has one largest coin on it, and the A is having n minus 1 coins, right? Now my next task that is only left is to move all the n minus 1 coins from the A to the D. So this is what I have written here. I move n minus 1 coins from A. I have to take it to the D, and I have to use third one as the auxiliary. So when I move n minus 1 coins from here to here, now the D is having the n points, S is having 0 points, and A is having 0 points. So this is my final state that I wanted to achieve. Now if I have to calculate what is the total number of steps, so steps needed in this step, the steps needed in moving from one point from the S to D, and then again the steps needed to move from the A to D will be my total number of steps. So this should be my total number of steps, which should be my answer. Is it clear?
Yeah, Vishwa.
Now let's try to write the recursive code for the same when we have understood the logic. So I write this function public and moves, and then I say that int n char a star char and cancel. So the first is the termination condition. Okay. So what I do is that if n is equal to 1, okay. So if the n is equals to 1, it means that I have to move only one coin. Okay. And if I have to move only one coin from S to the D using A as auxiliary, so I know it is only one step that is needed. So I simply return, and the method will get executed. So if I'm only left with one point, it can be only done in the one step. Now the second thing is that that the logic, this recursion part comes into the play. So what I want is that I want to move first n minus 1 coins from S to the A, right? So for that I have to call this function recursively, move n minus 1 coin from S, you move it to A, okay. And then what you do is you can store it like this, like in steps. You move from S to A, okay, and steps to move from will be equals to move n minus 1 and D and then A and then S, right? So my my answer should be steps to move from the S to A n minus 1 points plus 1 point that is needed to move from the remaining S to the D, and then moving the remaining points from the A to the D. And this will be my answer. The same thing that what I've done here is what I have written here. Same thing. So with this, the whole problem, and if you wanted, I could have written all these three things in a single line of statement. So the whole code gets solved in just like 3 lines of code using the recursion. One second, I think this one I have written is, sorry, this is A and B and then it's A, D and sorry. Yeah, you told me. I think this I have done a typo here. So in the recursion, the implementation is not that important. The most important thing in the recursion is understanding what is the method definition. And if you understand the method definition, you can use it to write a very nice, beautiful, and succinct recursive code. Is it clear now? Don't try to memorize, just try to think about the steps. Whatever the point that I told you, that whenever you're solving any recursive problem, you should be very clear about the method definition, and it's very important. And if you're clear about the method definition, you can always use it intelligently to make a recursive call, right? Does this make sense? Is it clear? Any doubts on this question?
Vishwa, I have
Yeah.
one question in the steps to move, right? So after in the logic plus recursion, right? For the first step, which you were saying that move n minus 1 coins from S to A using D. Okay?
Yes. Yes.
So if we see the stack of the queues, even in n minus 1, we have the last one, which is a big one. followed by the smaller ones. Imagine you have some cubes, right? Starting from let us suppose 10, 9, 8, 7. Okay.
Okay.
So these are n minus 1.
Okay.
So now you are planning to move n minus 1 from S to D, because D is the auxiliary. First you will pick 7 because it's the top layer, okay, and move to D. Okay. Then the next one will be you pick 8, and again you will move to D because it's a recursion one. But 8 is greater than 7. That means 8 size is greater than the 7 size. That means we are keeping a bigger one on a smaller one. But as per the one of the condition is that we shouldn't keep a bigger one.
So actually, to visualize that, what you can do is that, once you, so actually the way you are iterating is not correct, because of which you are saying you are putting a bigger one into smaller one. To visualize that, what you can do is that when you are solving this problem, you can just print it. Okay, so you can just print it every time when you're moving a coin from the one to the another, right? So in this, between this, you can just print one statement: move one point from, and this is S. So what you can do is that, so the one way is that you start doing the same approach with the 3 coins, because in that case it will simpler for you to visualize. You put this print statement, run your IDE, and see how the things are happening, and then you will realize that things are happening in the order, because the way we have written this recursive call, as I was explaining here, is that first of all you move n minus 1 point from the S to the A, right? And when I say that I move this n minus 1 from the S to A, I have done this using all the constraint that is there. How it is being done, this internally take care of. As of now, till here, I'm not worrying about the implementation detail. I just know that when I tell this moves function to move n minus 1 point from the S to the A, it will do that with, by following all the constraint that, only a smaller one can be kept at the top of the bigger one. The bigger one cannot be kept at the top of the smaller one. So using those all constraints, it has moved n minus 1 coins from the S to the D. And now the one that is bigger is left here. I just move it to the, by using one step, I move it to the step D. And then I move n minus 1 coins from here to here. So since here also I'm making sure that, the bigger coin goes at the bottom. So all the internal recursive calls will also take care of this condition that, always the biggest goes at the bottom. So whenever you write a recursive call, you try to follow a pattern in that particular function, and then when you call it recursively, it keeps following the same pattern inside that also. So we have made sure that when we write this function, we have first moved this, then we have taken this one step to move from S to the D, and then only I am calling this method. So that is why I'm added one in between here, right? So this makes sure that every time when you do this, constant of larger coming at the bottom and the smaller coming at the top holds true. And if you want to visualize this, in the interest of the time, I'll not do it, but I'll share this piece of the code. You can simply copy this code and try to run this. And I think then in that case you'll get a proper one by one that how the coins are moving from the one to another. Right?
But a final question, Vishwa.
Yeah.
So if there is 1 to n, we will move one first, following n. Is that right?
Yes, we'll have to move one by one itself. So for example, suppose n is equal to 3. Now here your doubts will get clear. So I have a source, I have a destination, and I have something called auxiliary. Initially it was 3, right? It was 0, and it was 0, right? Now I want to first move the 1 coin from the S, smallest one I have to move. So first of all, what I did, I moved the 1 coin here, and it was left with 2, and it was left with 0, right? And I can move this coin to here, and this is 0, and this is still left with the 2, and then I can move this further coin here. This still remains 1, and this remains 1. This again, this one I can put here 2, and here it is 0, and then it is 1. I put it back here, and then it is 2. Sorry, let me make this 0. So what I'm trying to do here is,
I understood your approach.
You got my point, right? So one after another, to keep on arranging it like this, and this is how the recursion will also follow, because one after the another size will count down, and this is how it has to go.
So for each step, we need to follow both the two move conditions in that case.
Yes, so this is what we are doing, right? For each of the steps, we have to follow this, right? And then and in between you have to move one also. So this will happen for every case.
Okay, I got it.
Right. There's another way to solve this problem, and it becomes very simple. So what you can do in that case is you can try to solve for 1, and the value will come out as 1. If you try to solve for 2, it will come out as 3. If you come out for 3, it will come out as 7. And if you come out as 4, if you calculate, it will come out as 15. So if you follow this pattern, it actually follows a pattern of 2 to the power n minus 1. Right, but this is a tricky way, so I'll not ask you guys to follow this step, because this will not always work, because you cannot rely on a tricky approach. But then this is a very fast, this is very efficient, because what you did is that you have to figure it out the pattern, how that is getting you the data. So it is basically a power of 2 to the power n minus 1. So you just put the value of n, you will get the number of times that you have. But this is a tricky approach, we will not follow that. So we'll just follow the logical one, which is the recursive. So I think we have covered this one, and I think I'm left with only one question in this sheet. Did you guys get a chance to solve this question number 5? How about this?
Yeah, Vishwa, so I tried with like for loop, so I was able to somehow make it, but recursion I was not able to like.
Okay.
So,
Okay, you are not allowed to use division operator. So with this, now you're restricted. You will not be able to solve using the for loop unless until you are using some extra space. So I'll suggest, I'll encourage you guys to try this question again, because this is again one very classic example of, just like Tower of Hanoi, it's a very classic example of very good use of recursion. So I'll try to encourage you guys to try it once again. We can take up this question in the next session if there's any doubts in there. What do you guys think?
yeah, I will like try again.
Perfect. Cool. Apart from this, I also gave you guys some assignments, right? I asked you to read about the sorting algorithm. The 3 sorting algorithms that I asked you to read about was, one is bubble, and then selection. So what is the time complexity of the bubble sort? What is the time complexity?
N square.
Time complexity is n square. So for each of the sorting algorithms that we'll talk about what is the time complexity, and we'll talk about how many swappings happens. How many swapping will happen in the case of the bubble sort?
Okay, so it will happen like n minus 1.
N minus 1 only swapping? Do you guys think that? What do you guys think? Like, is it like n minus 1 swapping that will happen, Paritosh?
It will depend upon the size, right?
Okay. Let me quickly write the bubble sort algorithm. Right? This is a bubble sort algorithm. This is what you guys have read. So why it is called bubble sort? Because every time the larger element will try to bubble from the bottom and will go to the extreme right. Just how when you boil water, the warm bubbles from the bottom and goes to the top. Similarly here, if you see, this is the outer loop, and every time inside the inner loop, if any element is greater than the next one, it will try to move to the right, and will keep bubbling to the right most point. So at the end of that, every time a larger element will try to move from the left hand side to the right hand side, one step at a time. So that is why I say that it bubbles through left to right, and we call it as a bubble sort. Right? Everybody is in sync with this bubble sort algorithm. You have read the same thing.
Yeah.
Right. Now to tell me how many times the swapping is happening. How, in the worst case, how many times the swapping will happen? What do you tell me? Approximate total number. It will be like linear. It will be quadratic. How much?
N square.
It should be n square. Okay. Manoj, you were saying n, right? And as per the Manoj, it is n. How about Srinivas, you?
It's n square, I think.
And how about the Vivek? N square.
Yeah.
Okay, so I think the n square is right. Manoj, I don't understand. Why did you say n? You have any logic for that?
Yeah, you have a first, suppose we have a first element that is 0th index, and we have to move in the worst case I'm saying, so that we have to move it at the n-1 place.
Yeah, so I think I'll tell you, I'll give you example and it will clear too. Suppose my
Okay.
is like this 5, 4, 3, 2, 1. Okay. So first time what happens is that I'm here, like I'll try to compare 5 and 4. So 5 and 4 was first swapping I did 4 and 5 it happened now. And it became like 3, 2, 1. Now the second swapping happened, right? So 4 and 5
Yes.
and it became 3 and it became 5. And then
Yes.
2 and 1. Then again happened 4 and
3, 2, 5.
2 and then 5
5,
and 1 happened
1.
and then again it's 4 and then 3 and then 1 and then 5 happened, right?
5,
Now
yes.
again when I started, then again the 4 and 3 will happen. I know.
Okay. Got it.
2, then 1, then 5.
Vishwa,
Yeah.
Acha.
I have one question I can ask you right now. Like in
Yeah,
this, see, my question is like, suppose, like if you compare this bubble sort only, just take two examples. Suppose if there is one array which is already sorted, okay. Now in this case, it won't be time. The time complexity won't be n square right here because the thing is already sorted and
Even if the array is sorted, you will try to check this condition. The swapping will not happen. That is true. In the case if the array is already sorted, in that case the number of swappings will be 0. But we will go inside the loop. It will check for that condition. So the time complexity will be O of n square itself, even in the case of you are given your sorted array.
But one more thing, like suppose if there is a algo and it is having best case and worst case, so can there might be two time complexity coming out of that. So
normally whenever so yes, so any algorithm has three kinds of time complexity as such. One is known as the best case time complexity, another is like worst case time complexity, and the third one is known as the average case time complexity, right? Whenever we have to write an algorithm, we always think about what is the worst thing that can happen and how can I improve it. So time complexity we only consider about the worst case time.
yeah, okay, fine.
So this is the code for the bubble sort. And a question for you guys now. Please pay attention. As right now, Paritos asks a question that what happens in the case if the array is already sorted or if the array is nearly sorted. With this current implementation, even if the array is sorted, if I call a bubble sort, the time complexity will be O of n square, right? Can we make any change in this particular function of the bubble sort so that it improves my time complexity? I may not have to run the loop O(n square times to figure it out if the array is already sorted, or even if the array is say nearly sorted, like almost almost all the elements are sorted except few elements. Like for example, it is like 1, 2, 3, and then it is like 5 and 4. So this is almost sorted. Only one element is misplaced, right? So in this case, again, I don't want to have a time complexity of quadratic. I just want to solve it very fast. Can I do something in this method called bubble sort to improve the time complexity? In the case if the array is nearly sorted, or if the array is already sorted, can I do something in this bubble sort so that the time complexity improves? Can you think of something?
Before entering the for loop, if we just check that the current element and the next element is greater or not, and if it is not, then only get into the second loop.
So here you want me to put anything, or here you want me
No,
to?
after this, yeah, after this.
What do you want me to do?
So just check whether the current element and the next element.
So current element is I. This is the last element. I don't have the access to the element in the
Okay.
last. The current element is I here now.
So if you increment the current element I plus 1 like that.
So this is the last element. Oh, this is the last element. So in the outer loop, we are going from the right to the left, and in the inner loop, we are going from left to the right.
Okay.
So in that case, right, we could say that array dot length minus 1 is always greater than array dot length minus 1 until we meet a break condition.
So what you tell me? What should I write?
I'm saying like array dot length minus 1 greater than
array dot length minus 1. So are you giving me this logic based on this particular input? Because here it is like this. It may not be like this. It may be like this also. So don't give me a logic specific to this particular problem. It can be like this. What happens in that case?
Okay. Then
Your logic was specific to the part. Your logic should not be dependent on the input. It should be independent of that. I'll try to give you guys. And so going onwards, my suggestion is that whenever you are reading any algorithm, right, and this improved bubble sort is not there on the internet. Mostly you will not find it. But if you understand an algorithm better, if you try to focus an algorithm better, you'll get many additional information out of it. So for example, in this case, can you tell me which piece of the code is determining that the array is not in the order? Can you tell me, if you just look at this particular piece of code from here to here, which portion of the code can tell me that, okay, there is some misorder in the code? Can you tell me?
The if
condition, right? The if condition. Now suppose if I tell you that this internal loop works for complete from the j equal to 0 to j equal to y, and in that none of the time my if block get called, can you say that all the elements are in order?
Yeah.
If I say that you run the complete inner loop completely, full inner loop from j equal to 0 to j equal to less than I, it ran for the complete one full iteration, and in complete full iteration none of the time this if condition was hit, if condition was true, then can I say that all the elements are in order?
Yes.
And if all the elements are in order, in that case it is already sorted, right?
But again, it's running 2 times, right? It's running
So,
n square times.
Yeah. So this is what intelligence that we have to brought in. So what we can do is we can put Boolean is already sorted equals to true, right? And only if it goes inside this, I'll set that Boolean as. And once this whole complete thing runs away, I'll check this is already sorted. And if it is true, what I do, I can simply break the outer for loop. So in that case, instead of a quadratic, it will run only once, and the time complexity will be how much? It will be O of n in that case. Did you get it?
Yeah, but Biswa, I have one doubt. So this will only work if it is already sorted, right? So if it is a nearly sorted, we spoke before, like if the last element or suppose 3-4 elements are already sorted and one we have to just swap. So in that case also it will go for n square, right?
So this just give you a little slight improvement over the previous one. Okay. What I'm saying is it has not made this algorithm a linear time algorithm. It's still a worst time complexity of n squared itself. But in certain situations, in certain problems, so suppose only the condition was like this 2 and then 3 and maybe 5 was here and then 4 was here, right? So in this case also you'll get a better time complexity because in the first iteration itself the largest will go at this point. So after the first iteration itself the situation will be like this 1, 2, 3, 4 and 5. So after one iteration it will come to this, and the second iteration it will know that it is already sorted. So it will again give you a near linear time complexity. Even if it is like this, even if it was like 5 was here also, even if 5 was here also, and you have condition like this, right? So all the other elements are sorted except the one element. So in the first loop itself, the 5 will go to the largest because the bubble sort, what happens in the largest element always goes to the right. The 5 will go to the right after the first iteration. And in the second time when it comes back again, it will see that it is already sorted. So what I'm saying is that with this particular one extra boolean that you have added, you have tried to improve the time complexity of the bubble sort in certain situations when you have already sorted array, when you have a nearly sorted array. Okay?
Yes.
Now, there is something called selection sort also. Public. Okay, so this is basically a selection sort. So as the name the selection suggests, in the inner loop you try to select the minimum element, and once you have selected the minimum element, you swap it with the index I. right? So it is almost similar to the bubble sort, but there's a few subtle differences. Here also, what will the time complexity of this one? And very straight, right? But in this case, what will the number of comparisons in the worst case?
It will be same, I think, n square only.
It will be same n square only. Who is saying this, Manoj?
No, it's the swapping alone you're saying, right? Okay.
Yeah, I'm just talking about swapping. How many times the maximum swapping can happen?
Yeah, it would be n square.
Okay. How about Srinivas? What do you think? What should be the
It's n square only, I think.
n square only? Okay. And how about Vivek? You?
Maybe n.
Okay, so Vivek is saying n. So the answer is n, guys. And let's see why. So swapping is not happening every time, right? Swapping is not happening every time. So what we have done is that once the complete inner for loop runs, in that I have selected what is the index of the minimum element at that point. And after that, only we're swapping with the index I. Right? So the swapping happens every time after once the complete inner loop runs, right? So the maximum time the inner loop can run is n times only. The swapping can happen only the n times, right? If it was happening inside this, then I will say that it will be n square, because in that case n square number of times this code will get hit. But since it is outside the inner for loop, it is here. So this line of code will get executed only till the number of times this for loop is executing, right?
Yep.
So in the terms of the time complexity, the selection sort and the bubble sort are almost same, but still I say selection sort is better, slightly better than the bubble sort, because in the case of the selection sort, the number of swap is less than the number of swaps in the bubble sort. In the bubble sort, it is the order of n square, and in the case of the selection sort, the number of swappings is of the order of n. Now, coming back to the relevancy of understanding the sorting algorithm, nobody will ask you at this stage of your career that you write a sorting algorithm. Nobody will ask you, okay? But they will definitely ask you a questions, the related algorithm where the how we are doing it right now will be helpful to you. So, for example, how I use the flag in the bubble sort, or how we are doing calculation in the case of the selection sort. These logic will definitely will be asked indirectly in the questions that you may face in the interview, or when you are solving the problems for an industry in the use cases. There also you can use this concept, right? So pay very strong attention to this small point, because the another seed that I'm going to share with you guys is based on the sorting algorithms. There will be no direct question of how to sort a particular thing, but at the same time it will be based on the logic that we are discussing as of now. Okay, so one extended question of this. So right now I have given you the bubble sorting algorithm by the iterative way and the selection sort algorithm by the iterative way. What your assignment is this, right? The bubble sort and selection sort using recursion. What you have to do is that you have to write a bubble sort and selection sort algorithm using the recursion. This is your one assignment apart from the seed that I'll be giving you. Fine? Any doubts on this?
No.
Perfect. The next assignment, this is one thing. The another pre-read that you have to do is that you have to read about merge, read about quick sort, and read again insertion. And when you are reading, try to do a careful reading of it. Try to think around those lines. How many times the number of swapping are happening? Right? Can I do anything in this code to tweak this, to further make it improve? Right? Try to think on those lines now. Right? Just don't blatantly read anything that okay, this is how it should go. Don't do that. Try to have a more focused reading in which you pay a key attention that where the swappings are happening, what are the conditional checks that are happening, how many number of times the swappings are happening. Try to pay importance to these all critical important things, and then you do it. Right. So basically, this merge sort and quick sort has a better algorithm, which is n log n. One important fact about the merge sort is that every language has a inbuilt sorting algorithm, right? Whether it's a Java or it's a Python or anything like that. So most of the language where you use the inbuilt sorting algorithm, the underlying algorithm that they use is mostly merge sort, right? That is how important this merge sort algorithm is. So please try to go through this sorting algorithm. I'll also try to share you a sorting algorithm seed. Try to get started with the questions in that. If you're stuck somewhere, no problem, because there might be few questions in that seed for which concept we have not yet covered. So there's no problem with that. But try to solve as many questions as possible from that. I think if you read the merge sort and the quick sort on your own, and then you try to attempt that question, I think it will be much easier. But I'm not expecting you to solve all the questions. Whatever number of questions that you have solved, that is great. So I'm again repeating the assignments for you guys is that the last question on the previous sheet of the recursion that you have to try. The second thing is that you have to write the the bubble sort and selection sort algorithm code using the recursion. You have to read about the merge sort and the quick sort and the insertion sort again, right? And you have to tell me like what do you think in which kind of use cases the insertion sort will be used. Okay, right? All clear? Any doubt?
Sure.
Perfect. Great. Then I'll just stop it now and stay safe, guys. And that's all. All the best. Thank you.